Since the dawn of history, man has looked to the stars for explanations to everything in his existence. Questions stemming from his curiosity about what's out there, to seeking answers to help us understand our existence here on Earth. Every culture around the globe has engaged in different aspects of relating our existence to the cosmos. Early efforts at astronomy, mythology, astrology, and various religions have all played a part in man's attempt to understand his place in the universe. Beginning during the 16th century, however, the old ideas about the nature of the universe began to give way towards the findings of Copernicus, Brahe, Kepler, and Galileo, among others. The revelations that came about by the use of improved telescopes ushered in an era of an exponential increase of our knowledge of the universe. Following in those footsteps, about 30 years ago, a group of amateur astronomers decided to build their own telescope. They called themselves Group 70, and their goal was to build that telescope using a 70-inch mirror. David Barroso, the current president of Group 70, tells about the origins of the project.
Yes, I'm the Associate Director of the Telescope Makers Workshop, which has a long pedigree here in the Bay Area. It goes back to, off and on, back to the 1920s. The class is taught over at Chabot Science and Space Center in the Oakland Hills.
As he explains the basics of mirror grinding, we see a very quick example of what the Group 70 mirror will undergo, only on a much larger scale.
You start off with your basic glass, and the question is that we have to operate on this glass in some fashion to curve the surface so that we can focus light. Okay, so let us just say that you have a piece of glass and you want to make the surface in such a fashion that light will focus so that you can use this in a telescope. You rub two pieces of glass together and back and forth becomes very monotonous, but over time, if you use the correct strokes, the bottom one will turn convex and the top one turns concave.
The principles involved in grinding a mirror are simple, while the actual creation of the desired curvature of the slow expansion glass is more complex. The critical factor in grinding of the mirror is maintaining the curvature of the glass out through the edges. After constructing a clean room within which to work, the group experimented with different ways to achieve that objective. When it was time to polish the mirror, the group came up with a polishing tool that, with its multi-polishing heads, was able to protect the integrity of the parabola all the way across the face of the glass. As their mechanical creation carefully worked its way across the face of the mirror, it became affectionately known as the lapster, and upon completion of this task, the group hoped for successful results from the next optical tests. With the successful test of the mirror completed, the starting gate was up and it was time to begin the run constructing the tube assembly. This compressed version of the construction activity will give you some idea of the building process. After trucking all of the components to the fabrication shop, welding and assembly gets underway. Before the heavy welding can be done, however, a series of tack welds must be done so as to stabilize the joints from twisting during the lengthy welding process and subsequent heat. When the machine work is completed and the tube assembly is sitting on its mounts, the last phase of construction includes attaching the drive units and preparing for the installation of the other technical aspects of the telescope. As we enter this stage of the project, we invite you to join our Group 70 community and to hopefully be on scene when this fully automated, prime-focused instrument begins scanning the nighttime skies. Thank you for being with us. Good night.